everyone, it is C++ time again, and today we're going to talk about functions. We're going to discuss what a function is. We're going to talk about passing in values by reference and by value. We'll also talk about prototypes, function overloading, and yes, we're going to get into templates. Now, if you've worked with C++ before and you're just watching these videos for giggles, I guess, you might be thinking, why are you touching templates this early in the game? Well, stay tuned and you will see. So first of all, what is a function? Well, a function is basically a piece of code that you can repeatedly use over and over and over. So let's say if we had standard cout and we wanted to say hello, and with a standard end line, we're saying hello a lot. All right, let's run this. Let's see what it looks like. Yes, there it is. We said hello many, many times. And there is a rule. Well, it's not a rule. It is a suggestion that if you do something 3 times or more, it's the dry principle. Don't repeat yourself. And generally what that means is create a function to do it for you. So you might think, well, this is a pretty straightforward case. It's not the worst thing in the world. Let's say you want to change hello to and change it to hello world. Well, okay, yeah, this is going to be a little bit more of a nightmare. How can we do this better? Well, let's use a function. I'll just call it print, and we will put in hello again. And then instead of actually doing this code, what we're going to put in is print. And we will do that a bunch of times. Let's run it again and see if it works. And it does. It says hello a bunch of times. Now, oh, we wanted to add world, right? Run it again. Look at that. So the way this works is when it gets here, it will actually go up to here, run this, and then return. And in this case, it will run it again, and run it again, and run it again. Well, that is handy. Look at all of the work it saved by adding it in this one spot. Now, there's other things that functions can do, and that is they can accept parameters. So let's say we're going to pass in a string, and that is the string we are going to display. Now, suddenly here, we can put in hello world. Yeah, okay, I ran out of things to say. I'm sorry. Now when we run it, it says hello and world. So this is a pretty basic example. It's literally one line of code. And it does seem a little bit overkill to do it this way, but let's say this actually did more. Let's say it also would tell us the string length is, and there we go. Now it'll also tell us the string length after each one. If we run this, hello and world apparently are both exactly 5 characters long. How cool is that? Let's put an exclamation point in there just to show that it's not thinking the number 5 is special. There we go. Now it says 5 and it says 6. So again, it's only 2 lines of code, and instead of having to do that, we could copy and paste that. But let's say there were like this many lines of code. Okay, this, rather than duplicating this logic over and over and over and having the word hello in here and then here and somewhere over and over and here, we can just pass it in. So this is the beauty of functions, is it allows us to create basically a tool that we can just call over and over. All right, let's keep moving rather than having our print up at the top. Let's say we want things to be done in the order that we see them. Just for example, this will give us an error. Don't believe me? There you go. Error code 1. Print was not declared. What? It's right here. Well, this is prototypes. Okay, so I skipped line 2. We'll come back to that. Prototypes are where you need to say, I'm going to just copy and paste. I'm feeling exceptionally lazy right now. You declare that this will be here when it needs it. Now if we run it, it works again. And that's because we're saying there's going to be a function called print, and it will take a string. And it goes, okay, I believe that that will exist, and then sure enough, later on, it does exist. Very handy. So you might be going, what's this by value by reference thing that you so casually skipped and absolutely had no concern about? Okay, fine, I'm sorry. What this is actually doing is when we type in hello, it is creating a copy. That it's not this original hello. And you might be going, well, that doesn't make any sense. What are you talking about? Okay, well, let's do it this way. Let's say we have my string, and it happens to equal hello. And we pass this in. And after it says hello and it says the string length, it's going to automatically append world to it for whatever reason. That is what we are going to do. All right, so in theory, what you would expect is this will start out as hello. It will say hello. It'll say that it's 5 characters long. And then it will turn into hello world. And then as we use our string down here somewhere, it'll be actually hello world. We will have changed it, right? Well, let's see what happens. We're going to use the little debugger tool here. And you can see my string is currently hello. When we run this, it is still hello. Huh. Why is that? Well, the reason is we passed by value. What we have done is we have created a copy. So the copy gets world added to the end of it, and then that copy is destroyed. So you might be thinking, well, there's got to be a way to actually change this original variable. And there is. What we do is we add this reference marker. It's the ampersand character. Now if we run this, oh, it's angry at me. Why is it angry? Undefined reference. Haha. We need to do it in our prototype as well. There we go. All right, now when we run it, you can see it actually changed the original one. So what this ampersand means is we're passing by reference. We're actually saying take this variable and give ownership and control and everything else its life to this print function. And the print function can do whatever it wants to it. And then once it's done, it will actually have affected this instead of a copy. So you might be thinking, well, why doesn't it do that all the time? Well, there's plenty of times if you're doing math and things, you don't want your original variables to change as it's maybe doing calculations along the way. You want it to give you the final answer, but you don't actually want to change the input variables that you use. And speaking of numbers, let's get into numbers. So we currently have dealt with a return type of void. And as you know, the word void means nothing. Nothing is being returned. We are not using the return keyword, and we are not returning the string or something like that. We are returning nothing. And this is assumed. You don't need to put in return unless you want to leave early for whatever reason from the function. But Let's do something that actually does have a return. So we're going to return an integer, and we're going to create just a little sum function here. Oops. I don't really want to deal with prototypes right now, so we're going to just keep it up high here. And let's get rid of our void return types. We've covered those. We're good. And we're going to pass these by value. We're going to create copies. That's fine. We're not going to change the first number. We're not going to change the second number. However, we do want to get a number back. So let's have an integer. We'll call it test. And it's going to equal the sum of 3 plus 5. Didn't actually write that logic yet. First number plus the second number. Cool. So let's run that. Oh, yeah, we're not outputting anything, are we? Well, let's fix that. All right, run that again. Now we have 8. Perfect. Let's say we want to do 3.4, 5.6. That should give us the number 9, right? Well, that's clearly not the number 9 if we step through this. Let's find out what we have here. It says test is 8. If I hover, oh, look at that. That says 3 and that says 5. It could be because this is an integer and this is an integer and 3.4 is not an integer and 5.6 is not an integer. Actually, I can guarantee that's what's going on. So what's happening here is if we hover over this, we can see that this is a double and it's not exactly 3.4, it's 3.3999999. That has to do with precision and what the computer's doing behind the scenes. We're not going to worry about that. It'll give us the number that we need. Basically, not much you can do about that. That is a computer thing. But what it's doing is it's basically casting these to integers. This is a C style cast, not a C++ style, but it shows the point in this example that it's converting 3.4 into an integer, which you can see gives us a 3, and when it converts 5.6 into an integer, it gives us a 5. Well, we don't want to do that. We actually want to get the number 9 in this example. So how do we do that? Well, we create a duplicate. You might be thinking, what happened to don't repeat yourself? It's coming. Don't worry. It's coming. So now we have the double version, and these are doubles. We probably want our output to be a double as well. Now when we run this, we do get a 9. Cool. What if we make this a 7? Run it. 9.1. I like this. The other interesting thing, though, is let's step through it. You can see it said 9.1, but inside the computer, it actually stored it as 9.099999996. So I do that to show you that when you are debugging, if you see numbers really wonky like this, don't worry. The it'll take care of it for you. But yeah, it's computer stuff. I'm just going to say that because we don't need to dive in that deep quite yet. All right, anyway, next, you're probably thinking, well, you wrote an integer version, you wrote a double version, there's floats, there's long doubles, there's longs, there's long longs, there's shorts, there's chars. Are you going to do that for every single one? Are you going to do that with unsigned integers, signed integers, unsigned chars? Okay, yeah, no, I'm not going to repeat this exact logic, this line of code over and over and over. And that brings us to templates. So actually, function overloading is what this is. We've overloaded this function to handle different parameters and to return a different type. That is a C++ feature, not a C feature. Fancy stuff. Let's talk about templates though. Let's find a way to make the computer do this for us. Well, there is a way, and it's called a template. We're going to say we want a type name, and this is where you get to be creative and come up with the name. Some people use the letter T or capital T. Let's use the word type. Let's explain what we're doing so that we're not just creating chaos. And we want to return that type. I'm going to just stop talking about what I'm typing for a second and see if you realize the genius that you are becoming by working with the C++ language. You might have noticed that wherever we used int before, now we're using type, and wherever we used double before, now we're using type. If we get rid of this, will this actually work? Huh, that actually worked. How did it know? Well, it saw that you were passing a double in, and it was able to figure that out. Let's try that again with just integers. Let's run it again. Yep, that worked. You might be going, well, but that's fine, but we know with this example it's a double, but I really want to get a float out. I want a single precision instead of double precision. How do we do that? Because it's passing in doubles, it's probably going to assume this is a double. Actually, if we run this right now, it doesn't tell us if this is a double or a float. What it's probably doing is giving us a double and then converting it to a float. That might not be exactly what we want. And when you're not working with numbers and you're actually working with classes, it might not be able to figure all that out for you. So how do you tell it specifically, use a float? Well, like this. What you're doing is, and I honestly, I would recommend doing this all of the time. Don't allow the compiler to assume things. It might assume the wrong thing, and you might be chasing your tail for a very long period of time. When you get into classes and structs and all the cool things down the road, it might not make assumptions and the compiler will just yell at you. So I'd say get in the habit of doing this. But anyway, what we're saying is this type is a float. So it will put in float for all of these spots for us. If we were to change this to an int, this would be interesting because it'll convert this to an integer, I believe, this to an integer and give us an integer back. So this should be 8 plus, it'll give us 9, 3.5, 5.5, give us 9. But I have a feeling this will give us an 8. Let's find out. It did. Reason for that, it converted this again into an integer because we essentially replace these with ints. So 3 and 5 give us 8. And then it said, well, actually, I want you to be a float, but it already had the wrong number because of the way we did the math. Hopefully that makes sense. But the coolness here is if we run this multiple times with doubles and floats, and it's going to yell at me because I already created that variable, but the computer essentially is writing this for us. So if we were to say, instead of summing, I want you to do a whole bunch of stuff right here before you sum it up, we only have to write that once, and the computer will automatically write all of the versions of the function for us. It essentially, behind the scenes, will write this for us for each type. So anyway, that is all I have for you. I hope that you enjoyed this video. Please like, please subscribe. We look forward to seeing you in the next video. And continue on your C++ journey. It is just beginning to get exciting.